My model of human preferences is that the status games between humans lead to increased welfare for dogs.
You were saying that if the world was only one human and one dog, then the human would eat the dog. I don't think that I would unless I was really hungry.
If we reframe the alignment problem as the alignment of the equilibrium among AIs, maybe that can be a productive avenue for progress.
The fundamental difficulty is that none of these superintelligent AIs are aligned or controllable. Welcome to Doom Debates. My guest today is my friend Gil Mark. Gil and I have actually known each other for 16 years. Back in 2009, when I was starting my first startup, he was my co-founder's 17-year-old intern. Since then, he's had a great career as a product manager in the Silicon Valley scene. The original startup failed, by the way, but he currently works at LinkedIn, and he leads generative AI products for advertisers. And I invited him on the show because he had an interesting idea about how AI alignment might be easier if we have more than one. And he and I argued about that, but he still wants to discuss it further. And I think one of the values of this show isn't just to hear AI luminaries talk about why we're not doomed and be wrong, but it's also to hear more amateur people talk about why they think we're not doomed and have me argue against them too. How does that sound, Gil?
That sounds great. Yeah, I'm happy to be on as an amateur. Does that mean you're going to go a little easier on me?
Yeah, it does. And, originally when I thought of doing a podcast, I just envisioned it as the random back and forth that I have by Twitter with like anonymous accounts, just inviting them on so we could hash it out and maybe other people could hear like a longer discussion. I didn't even think about like, hey, if we get a big audience, we can start inviting more and more recognizable names and actually turn it into like a world debate forum. So my ambitions have definitely grown. I think they're good ambitions. I think a lot of people support it. So I like where the podcast is headed, but I still think the other idea of just like ask people who don't think about AI doom all day what they think and why they think we're not doomed. I think there's still value to also doing that. So thank you for indulging me and in case you're right, thanks for having these ideas.
Yeah, no, thank you. Thanks for having me. I think my exposure to not just AI doom, but AI in general and tech is very much thanks to you and your co-founder at the time. So it's cool to have this little reunion, get to come back and talk with you about some of these ideas. I haven't worked in AI for a long period of time, but of course, we worked together at this startup. I think we had folks like Eliezer Yudkowsky and other people around. And so like I was exposed to these ideas years and years ago. And so it's not something that I think about every day, but it's something that I've thought about for a little bit over a long period of time. So it's cool to come on and chat with you. I appreciate you having me on.
Awesome. Yeah, this is going to be fun. And that's a good little piece of history, right? I mean, back in 2011, 2012, when nobody was thinking about AI doom, we were a long way from ChatGPT back then. But as you say, I was involved with Machine Intelligence Research Institute and occasionally hanging out with Eliezer Yudkowsky and a lot of those people. And he did actually come to our startup and give us a couple talks and do rationality camps with us. And yeah, it was good times. And it's crazy to think that now the whole tech industry is like laser focused on a lot of the same issues.
Yeah, no, things have changed a huge amount. How do you keep up? How do you stay caught up with everything that's happening?
Well, I don't think that I keep up with every development. I think I just put everything into context of the big picture of like, hey, the intelligence looks like it's getting higher. I feel like that's the main takeaway here, because I like to reframe things with like, look, it doesn't matter how the current AI system works. It just matters that now it's this smart, because there's a lot of predictions we can make about things that are significantly smarter than us, like instrumental convergence and like they're not going to figure out to be moral unless they start out being moral. Like these are the kind of predictions that it doesn't really matter. Like, oh, we made the transformer architecture more efficient. It doesn't really matter how we get there, because there's a whole science of what it looks like when we get there.
Yeah, no, I get that, and it makes sense. One of the challenges that I have in terms of reasoning about AI in the same way that you do, right, is I think I think reasoning by analogy is really helpful, and it sounds like a lot of the way kind of you frame the kinds of problems that we're going to have with superintelligence is really different from the kinds of ways in which we can project like our relationship to lesser intelligent species on Earth. Like we can't learn from our relationship with dogs, or we can't learn from our relationships with other kinds of animals and plants that exist. And this is something that's like fundamentally different. Is that the case?
Well, I would argue that we totally can learn. I just think the most educational relationship is our relationship with ants.
Okay. And what do you mean by that?
Because we're much more powerful than them. And there's no intuition that we have a non-zero sum relationship with ants. It's clear that we just sweep them out of our way and then do whatever we want.
Yeah, that's true. But let's say that the growth of human population has resulted in like even more ants existing on Earth and thriving. And yes, and sometimes maybe we find a colony and like we sweep them away and do whatever we want. But there's like, 1 trillion ants alive on Earth today. But like, I don't know, 100 years ago, there was only like 100 billion alive on Earth. Like, what if ants were thriving under like human civilization?
It's just because we haven't turned the whole Earth into stuff we care about yet. If you look at the part of my house that I care about, there's 0 ants. And yes, Earth has some nooks and crannies that I don't care about yet, but I'm not done transforming Earth.
So is your prediction that ants will be extinct? Let's hold aside like, superintelligence for a second. Like that ants will be like extinct at some point if we don't develop superintelligence because we're going to care about all the parts of Earth and like the ants are just going to die?
That's a great question. If we're always limited to 180 IQ or whatever you can get out of a current human brain, we might just never have the kind of focus to transform every atom on the Earth to be highly optimized. So we might just always have a lot of parts of Earth that we treat as waste. So our percentage of utilization of Earth's resources is always going to be like less than 30% or whatever, right? Well under 100%. It's just if you have more intelligence, you can just have a nanomachine that has enough intelligence to go off and increase the utilization, right? I mean, Earth is giving you a bounty of resources. And if you want to ignore some of the resources, maybe a human level intelligence will just ignore the resources forever. But that's just not the convergent outcome, right? The convergent outcome is you amplify your intelligence and then you're able to use more of your resources to get what you want instead of to just not care what you get.
Is it that we're treating parts of Earth like waste, or is it that they're like we see some like intrinsic value to like natural environments and like environments as Yosemite, right? Like we like that Yosemite's there, like we don't want to turn it into something else. Like we've never built a natural preservatory for ants. Yeah, that's true. But like the ants have. Yeah, we haven't built a natural preservatory for ants, but like our activity on Earth has not necessarily caused them to go extinct, right? In some sense, maybe they thrived under our leadership, if you will.
Yeah. So the thing about intelligence is what happens becomes pushed toward what it prefers, right? So the idea is it's manifesting preferences. That's what intelligence does. And that's what's convergent, because if you start manifesting preferences a little bit, the convergent outcome of that is you manifest preferences a lot. Like I often talk about AIs converging to being hardcore, just because if you have a slight mutation or a slight improvement where you have another version that's more hardcore, that version is going to be more competitive. It's kind of like evolution. Organisms are hardcore on dimensions that they can access with local hill climbing of genes. So like what I'm saying is like there's no super obvious improvement that you can make to like the human eye architecture. You have to like pull back a bunch of ways that it's architected before you can then drive forward on some other axis, right? It's like a local optimum. So the local optimum of intelligence is competing to optimize things. They can get better in like a much more unconstrained way. So you're already seeing evolution on Earth make a lot of very hardcore, red in tooth and claw, a lot of fighting, a lot of like powerful organs, but then it kind of gets stuck and you don't see that process go all the way you're going to see it with self-improving AIs.
And why is that process going to go all the way with self-improving AIs in the way that it doesn't go all the way with non-AIs?
Right. So this is the question of just like, why am I claiming that hardcore goal achievement, goal orientedness, why is that a convergent outcome? So first of all, why do goals naturally emerge when you're just trying to do anything? Like, hey, all I'm trying to do is run a business. Why do I become very goal oriented? Well, having a goal helps you solve any problem. So if I'm running my business, if I want to make more money, first of all, that's already a goal. But even if that's my only goal, it's going to help me if I'm allowed to have other goals. So if I'm allowed to have the other goal of like, okay, well, find me the cheapest vendor who can deliver a new building for me on time. That's going to help my business, right? To build a new storefront on time. So if I can keep that goal in mind and I can analyze the probability that things will help that goal and the cost of doing those, like all the standard playbook of achieving a goal and a sub goal, that just helps you solve problems. So everybody gets to that same idea of like, let's keep a goal in mind. And then you get this idea of expected value. So you choose actions based on which is going to get you the highest value in relation to a goal. So all of this is very convergent stuff. There's even a bunch of theorems saying if you try to just do something else, to the extent that you're cutting against this kind of like expected value analysis, you're just like contradicting yourself. You're slowing yourself down. So, I mean, are you kind of following the part? Are you okay with the part of saying like, okay, agents tend to have goals and sub goals, and maybe where you get off is like, well, why are they going to be like so hardcore about them? Why can't they just like do them casually? Maybe that's where you get off.
I think they're going to be, yeah, no, I don't think I'm disputing that, or even that they're going to be so hardcore about them. Maybe it's more that you're saying that there is going to be some recursive process of like self-improvement on how they achieve those goals that's going to top out at infinity, or top out at some level that's much higher than the process that happens, for humans or for ants or for other kind of organic beings.
I see. There's a few different parts of the claim. So one part of the claim is that there's a lot of headroom above human intelligence. So I'm imagining a world that's full of agents that if you talk to them, it's like talking to somebody smarter than Einstein, basically, right? So would you believe that?
Yeah.
Okay.
No, I would believe that.
Smarter than Einstein, that also has way more knowledge than Einstein's brain could ever hold, that also runs hundreds or thousands or millions of times faster, right? So even just you saying one word to it, it could have already done like Einstein's career. Like, is this all plausible to you?
I think it is all plausible to me. I have like a bit of a nitpick on the speed one in particular, but we can like come back to it later.
Okay, so headroom above intelligence is one part of the claim. And then another part of the claim is like, okay, well, if we were smarter and faster, could we go and get to the tech tree of high? You know what I'm saying? Like eventually, if you give us enough time, we're going to build these really much smarter than Einstein entities. So now it's just a question of like, okay, well, do you think we will get there in like a few decades or like at some point? That's one of the claims.
Yeah, I mean, I'm not exactly sure that I know when we're going to get there. I feel like I don't have a strong opinion on a timeline specifically.
Okay. Does it seem pretty likely that we'll get there in like less than a century?
Yeah, potentially. Yeah, and yeah, less than a century less than a century seems very reasonable.
Okay, so we're talking like our grandkids type of thing. So like by the time your grandkids are trying to grow up, there's going to be this force that's just like much smarter than anything that's ever existed on the planet. And we've seen the impacts that humans had on the planet. So then going back to like my original claim is like, okay, well, why would that kind of entity have this convergent outcome where it just seizes like every possible resource on the earth? So, every bit of structure and energy and, uses its time efficiently. Time is kind of a resource. All the light entering the earth, all the minerals, right? Just everything that you can construe as a resource. You're not just going to have resources lying around. Every resource is going to be put to work, basically. Like that I claim that that's the convergent outcome. So you're still not buying that, right?
I think so. Yeah, I'm buying that can happen. I think it seems to me like there's a lot of steps along that path, right? And there's a lot of opportunities for us to like get off at a different exit, right? And set things in a different direction before we get to that point. Like, yes, in theory, that seems possible, right?
So there's ways for us to get off and avoid it, but I claim that it's a convergent outcome. And it's not even clear that we're explicitly trying to avoid that outcome. So a lot of people might just be like, yeah, that's totally fine. Use every resource, be goal-oriented, just have the right goal, right? That's like a popular opinion.
Yeah, I mean, I think the question of, a single agent having a single goal and being goal-oriented seems like, and being all powerful in the way that you describe, I think it seems like a problematic scenario. Like I don't disagree with that, right? I do think I have a couple of different scenarios that I think could basically like play out. And if we have an agent that's, super intelligent and it has a goal and that goal isn't perfectly aligned to human well-being. And I think the first one is like, I kind of wonder, how do you think about kind of the value of like a single threaded intelligence versus like many different threads of intelligence, kind of optimizing their goals, somewhat independently of each other, right? Like, what's a
Right.
scenario like where we have like some mega super intelligence, right? That is much smarter than humans, but we still have, whatever, 7 billion other threads of intelligence that are
Right.
optimizing their own goals. Like, how do these two systems interact with each other?
Okay, so this idea of like what happens when there's multiple intelligences competing or trying to cooperate, I think this is the heart of where you and I were going back and forth and persistently disagreeing. So this is going to be the heart of our conversation. But before we get into it, let's just level set here. I got to ask you the big question, okay?
Okay.
P Doom, P Doom, what's your P Doom? What's your P Doom? What's your P Doom?
Gil Mark, what is your P Doom?
1% or less.
Oh, wow, only 1% or less? Okay, why is that?
Yeah. Well, I think it comes to this question of how do multiple intelligences interact in a system. Both if we consider a scenario where there's one single super intelligence and 7 billion human intelligences, or the potential scenario where there are multiple kind of super intelligences and 7 billion human intelligences, right? I think these are like pretty complex interactions that don't necessarily like converge to the point that you're pointing to. And so I think I see it as like a 99% chance that those two kinds of systems don't necessarily converge to your point.
Okay, so I guess that's when I would call your stop on the doom train. It sounds like you're riding with me on a lot of the early stops. So I'll tell you a stop on the doom train and you tell me if you're still riding toward doom, okay? So like the idea that you can have a silicon brain that's much smarter than a human brain, you're still riding along?
Yeah, along at least some dimensions, yes. I think the precise definition of that is hard, but
sure, like
generally,
much more
yes.
powerful, right? Like whatever Elon Musk does, like imposes his will on the world, you could have a silicon brain that imposes a will even more effectively. Okay. And like significantly more, right? Not just like a little more.
Sure. Yeah.
Okay. So you're following that step on the doom train, and then there's the orthogonality claim, which is the idea of like you can have this kind of major superhuman, headroom above humanity, like much smarter than human brain, and that kind of brain might plausibly just not care about human morality, correct?
It might not. I think I probably believe less than you do that it won't. But it might not.
Okay, significantly might not. So that's the orthogonality thesis. Just like even significantly considering that it might not that's the idea. Okay, and then there's instrumental convergence, which I think you were pretty okay with when we touched on just now, which is just the idea of like, look,
it's
you
goals,
have all these.
it has a goal, and it's it's optimizing like sub goals so that it can achieve that goal, and it needs to stay alive in order to achieve that macro goal that it has, right?
Right. So if I told you as a hypothetical, let's say OpenAI's next model is actually way farther in the lead than we realize, and it can kick off its own recursive self-improvement, and it's the only AI that's at that stage. At that point, would your P-Doom get really high?
My P-Doom would get significantly higher, yes.
Okay. But you think that scenario must be really unlikely because your total P-Doom is only 1%.
Yeah, I think that scenario is pretty unlikely.
Okay. All right. So your stop on the doom train is basically, look, an individual AI is pretty doomy, but there's going to be lots of different forces, and somehow the forces will balance in a way that humanity gets to survive and have a decent future.
I think that's maybe a little too facetious for my argument, but I think that the situation where there are multiple forces is like one worth considering, because if like we're in that equilibrium right now, right? Like there are multiple AI labs, there are multiple like competing super intelligences. They're all going to be like moving to get more intelligent, in the way that you described, somewhat in parallel, right? And so I feel like we're closer to that world where there are multiple competing forces than we are to a world where there's a single that dominates, right?
Okay. All right. So now let's get into the meat of the argument, which is just like, what happens when you just have different AIs emerging and they all care about optimizing goals and they're all super intelligent? Like, what is the result? I claim that the fundamental difficulty is that none of these super intelligent AIs are aligned or controllable. They both have major problems with like having an off button or doing what we actually want. They all just like to cheat on our tests until we basically let them go accidentally. And so you have all of these unaligned AIs, and the result of a bunch of unaligned AIs talking to each other and splitting the universe among each other just doesn't help us as humans. So it's like if you have a bunch of different, the analogy would be if you have a bunch of different human countries, and the human countries have a lot of geopolitical conflict and geopolitical trade, that doesn't help the ants, right? So I would make that analogy. So that's my claim. So what's your counterclaim?
I think that question of whether or not it helps the ants or not, I think is kind of an interesting one, right? Because it's like, if there are multiple super intelligences, you're saying they're just going to split the universe amongst themselves, right? We're going to get to this world of like multiple super intelligences, and they're not going to have some kind of persistent misalignment, disagreement, like way in which they can't exactly predict the other's behavior, because they are both super intelligences and in some sense, by definition, can't fully internalize the workings of the other, right? So like they are going to be in some sense on an equivalent level of intelligence, and they're not going to have predictable game theoretical, interactions between each other, right? And so like you're saying, like there's going to be like there's going to be this world where like we're going to have super intelligences, they're just going to agree, they're going to negotiate the outcome of a conflict before it happens, or they're going to make an agreement, and then they're just going to decide to like go their separate ways. There isn't going to be some kind of ongoing interaction between the two, which is kind of a dynamic system, some kind of a relationship that isn't perfectly like harmonious or decided on day one and never revisited again.
Okay, so you're asking me a question basically about super intelligent game theory. Like, what is the Nash equilibrium, or what happens when you have a bunch of goal-oriented parties and they have different goals, but they all have power, and one of them can't snap their fingers and eliminate the other ones like we can do to ants within like a small enough region. But you don't have you have a balance of power, not an imbalance.
Yes.
So what do? Do they all destroy each other and nobody gets any value, or do they manage to cooperate and even like trade and create more value? If you look at humans, our game theory has gone pretty well for whatever reason, right? We've managed to not actually nuke ourselves and destroy the world. It sure looked like during the Cold War, it looked like it was just going to end and nobody would get anything. Like we would just all die, even though we didn't have to, because we were just that, the game theory was just pushing us toward this inevitable outcome where we just all nuke ourselves and we all die. Kind of like the prisoner's dilemma, where in a lot of prisoner's dilemma situations where the prisoners have no respect for each other, like two prisoners who truly hate each other's guts, they're not like friends trying to team up, they probably would both defect on each other in the prisoner's dilemma, and they probably would get a worse outcome than if they both cooperated. So there's a lot of human game theory situations where it's kind of like a shame. It's like a tragedy of the commons, right? Like you burn a common resource. And so then the question becomes with AIs, is AI cooperation like a nuclear war or a tragedy of the commons, or is it more like the trend of the human economy where we've managed to be positive sum and not destroy ourselves and give everybody what they want? Eliezer Yudkowsky has actually spent a lot of time on the subject, and his suspicion is that super intelligent AIs are smart enough to face a true prisoner's dilemma, where humans would tend to want to defect in a true prisoner's dilemma, but the AIs would be smart enough to cooperate. So he has some writing on that where he's like, listen, if there's kind of obvious ways of being a certain way to get value, the AIs are going to figure out to be that way. Eliezer Yudkowsky has this intuition that super intelligent game theory is cooperative whenever there's positive sum to be cooperative. That said, when you and I are talking about the application of all that to human welfare, I would argue that it doesn't matter. So whether the AIs just destroy each other and just leave the universe to be pure heat, or whether they divide up the universe into however many segments that's creating lots of value for the AIs, neither of those cases creates value for humans.
Is it not possible that one of those segments that they divide the universe into is one in which like humans are like thriving and like having a wonderful time, and there's abundance for all of us? Like those segments create shards which all have like different possibilities, different possible futures within them, right? Like does that not, like is there no space inside those shards where we could be like doing great?
I think that there's a great shard if and only if we were able to create one of the AIs which is aligned, right? So originally I made the premise that I don't think any of the AIs are going to be aligned. You can feel free to push back on that premise. But if you don't push back on that premise, if you accept my premise that none of the AIs are going to be aligned, then I don't see why one of the shards would have human value in it.
So I think my argument comes down to this notion that I think I don't know. I don't have a solution to the alignment problem. Like, I don't know how to make any one of the individual AIs aligned. But to me, it seems like the solution to this question may lie in this region of like, how do we make the intersection of multiple AIs result in both of those AIs being aligned rather than a single aligned agent, assuming a system with a singleton, right? And that in order to solve that problem, you actually have to add more AIs into the system, because in the same way that we do not care about the ants, right? We're much more concerned with our interactions amongst each other, and the ants, like they live in kind of their own universe. They thrive, like they live off our food in some sense, right? Like they exist. They're probably doing great in human society, right? Like this scenario where there are multiple AIs, they're negotiating with each other and they're doing stuff, like, yes, maybe it results in some like bad consequences for humanity in some at some points along that journey, right? But like there's this possible equilibrium where the AIs are basically agreeing that it's like good for humans not to suffer, or they're in some other sense mutually reinforcing an aligned scenario, right? In the same way that, like, you know, people, I'm going to switch the analogy from ants to dogs for a moment, right? But like, because dogs are like present in our lives. Like, why do we care for dogs? If let's imagine like a fictional scenario where we had on Earth one human and one dog, right? Like, what would happen? Does the human like kills the dog and eats it? Probably, right? But we have like a scenario, like we have an Earth where we have like 7 billion humans and we have like a lot of dogs, and the dogs do great. And the dogs do great because we have this like status competition amongst ourselves for like who can be the best dog owner. And we have dog Instagrams, and we have, it's like this whole thing where it's like caring for the dogs is a byproduct of like thriving human society, right? It's like, can we make caring for the humans a byproduct of a thriving AI society?
Okay, do you have a dog?
I do not.
Okay, well, if you owned a dog and every other human and dog died, you would eat your dog?
If I owned a dog and every other sorry,
I'm just unpacking your scenario here, because you were saying that if the world was only one human and one dog, then the human would eat the dog. And like I don't think that I would, unless I was really hungry.
I'm saying that it's like a doomsday scenario. Yeah, there's no other food. Like you know, you like, what are you gonna do, right?
I mean, if there's no other food,
like
I would eat my friend, right? I mean, like sailing parties would have a deal where you got to eat somebody, right? If you're stranded.
Sorry, say that again.
I'm just saying, like, I would eat anything if the conditions were sufficiently dire, right? Like shipwrecks,
right.
Like people would start eating each other.
Yeah, exactly. So I'm saying this scenario where there's like one AI and it's going to, you know, destroy all of the value, right? To me seems like, yes, like if the AI has a goal and human society is in the way of like optimizing towards that goal, and like we're the only thing that like stands in the way of it achieving some outcome that it has in mind, right? Yeah, I think there's probably a lot more danger. But if there's a system where there's multiple AIs achieving multiple different kinds of goals, there are possible equilibriums between those AIs where humans are doing great.
Okay, so let me just summarize what I think is your argument right now, because it's quite interesting. I can't say I've heard it before, but your idea is basically like an individual human doesn't value dogs. But when you put the human in a society,
may or may not. Let's say may or may not, right? Like let's say there's a coin toss on whether or not.
But may is cheating, because if they may, then you already win. You already have a human who values dogs, right? And that's like my premise. I'm saying none of the AIs are aligned. If you're saying, oh, no, one of the AIs is going to be aligned, then we don't have to have another conversation. We can just talk about whether one of the AIs is going to be aligned. Because I agree that if one of the AIs is aligned, then that makes P Doom a lot lower. I just don't think any of the AIs will be aligned.
Yeah. Okay. Then let's yeah. So I'll go with your scenario, right? Like, let's say, yeah, a system with one human, one dog, right? There's no other food. It's a doomsday scenario. The world has ended, right? Like, okay. There's nothing else to do. What happens?
Right. So if it's not a doomsday scenario, because I feel like I was trying to follow your story, and I thought you said, hey, if you just have a single human with a dog and like nobody knows what the human's doing with the dog, then the human would tend to just eat the dog. But because of peer pressure or like status games between other humans, then the human suddenly becomes more interested to take care of the dog. Like that's your model of human preferences?
My model of human preferences is that the status games between humans lead to increased welfare for dogs.
Right. So I think I just disagree with your base scenario here, where like if you have one human with a dog, I know if it's doomsday and that human is about to starve, I agree. I think most humans would probably eat the dog. I would eat the dog, frankly, right? I'd feel pretty good about eating the dog if I'm about to starve and there's no other food source. But why is starvation part of your scenario here? I thought you were trying to give an illustrative example of how adding other people into the mix is what changes things.
Yeah. So let's so in the same way where like in the scenario where there's one human, there's one dog, there's no other food, right? In the same sense that you're laying out the scenario where there's a superintelligence, it has a goal, it has no other way to achieve that goal, or its easiest path to achieve that goal, like staying alive or making it to tomorrow or whatever, right, is to go through human civilization, right, to destroy everything that we care about, right? Like there's that same kind of single tracking of the goal for the superior intelligence in that system, right? Where it's like the superintelligence, like it has some goal, it's not aligned to humanity, and it needs to destroy the things that we care about in order to achieve that goal, right? The analogy that I'm drawing is in a system with one human, one dog, it's a doomsday scenario, there's no other food to eat. The human needs to make it to tomorrow. That's their goal, right? And like the only way they're going to make it to tomorrow is if they eat that dog, right?
So why do you think we should model the AI as being in the equivalent of starving or doomsday? It seems like the AI actually has a lot of slack to maneuver.
In what sense does the AI have slack to maneuver?
So like imagine you're a super intelligent AI and you're just, even if you're just one AI, so you don't even have group competition, you're a super intelligent AI, you're unaligned, but you can do whatever you want with the universe. You're not under tight constraints. So you're not starving, meaning like you have plenty of resources. You can just decide what you value the most and you can get it. And you don't have to make huge trade-offs to satisfy fundamental needs. So in the case of the human starving, it's like, okay, yeah, you have to not starve, even if it means hurting a dog, which you otherwise like. But in the AI's case, if it just likes people and it likes getting electricity or getting energy, it can just do both. And there's no huge trade-off where people versus electricity, usually that's not like a main trade-off that the AI has to be obsessed with. Usually I, as a human, I like dogs. I don't have to obsess every time I see my dog. I don't have to be like, oh my God, am I going to be able to live? Am I going to starve, or should I eat this dog? Like those two things aren't normally the two things that trade off. So you put me under like a very stressful circumstance that I don't think is analogous to the circumstance of the AI considering humans.
Yeah, I think that's a fair counter argument, and I agree with that. I agree with it. And so I guess what I'm saying is not that the solution to alignment is in having these like multiple AIs, but it seems to me like the solution in maintaining the robustness of alignment once you have it is potentially in having these multiple AIs in the system, right? Because they are going to maintain the equilibrium on each other because they're going to be in competition, in negotiation, in a continual dynamic with one another, right? And so yes, okay, you have to solve this problem of having one of them be maybe at least a little bit aligned, right? But once you have that, if you have multiple of them, you're likely to avoid this problem of them recursively self-improving out of that alignment, right?
Okay, it sounds like you're making a pretty big concession here. It sounds like we're talking about stone soup, and you're telling me you can make soup out of a stone, and now you're saying like, okay, well, you do need like some vegetables. Like it's like that's what you're telling me right now.
I mean, no, I wouldn't go that far. I think I made the same claim when we were chatting about this before, right? Like I wasn't saying that this is the quote unquote solution to alignment. I was saying this is the way in which you could keep the alignment in place once you achieved it, right? And you would avoid this recursive self-improvement out of in a way that would harm that alignment, right?
Okay,
if you had like
the question just because like how much alignment do we need to start with, right? Because if you're saying we need a lot of alignment, then we don't disagree, right? Because that's my claim.
So I think, so I mean, so I guess the argument really is that maybe we need less alignment than you think, right? Maybe we just need a little bit of alignment. And then as a result of there being multiple AIs that are just a little bit aligned, right? then we can have a system that's robust and maintains human welfare for the long run.
Okay, well, let's try to unpack a little bit aligned, right? Do you want to maybe give an example of an AI that's a little bit aligned?
Yeah, I mean, I don't know that I can draw one out of a hat, but I think it reduces the complexity of it, or I'm sorry, it doesn't reduce the complexity of the problem, but it in a way gives you more tools to solve the problem of like robust alignment, that you have multiple AIs that are going to be in some kind of dynamic with each other, right? So I don't know that I can come up with an example of an a little bit aligned AI, right? But I think there's this claim.
One idea.
Sure.
Well, one idea is you can imagine that there's like a satisfying solution to the alignment problem. And then instead of having an AI that is built to embody that solution, coherent extrapolated volition, like fully realizing what the ideal human civilization would have done, but faster, instead of going that route, an AI is like, oh yeah, I get it. I get the ideal route for you guys. And I'm going to give it to you with 10% of the universe. And for the other 90%, I'm going to make paperclips. So I think that's a pretty coherent hypothetical. It seems highly unlikely because it's like if an AI knew what we meant and wanted to do what we meant so much that it was going to do it 10%, I feel like it's pretty easy for it to do it 100%. But at least we can talk about this hypothetical of like, okay, you have a bunch of AIs that are all 10% aligned like this. So the fact that they're now all in a big group, how does the group help? I feel like we're still just going to reach our potential times 10%.
If they're all in a group, right, and there's like they're all 10% going to give us that ideal path in some sense, right? Is there not a possibility that they start competing with each other to provide a little bit more than 10%, right? Like they're trying to do a little bit better than one another. What's that?
I mean, normally people, they compete in order to impress somebody else. Like if they're playing a game where you have to like win the game, or that you compete to win a game, or besides that, you don't just compete, you don't change your preferences just because other people also have preferences, and their preferences are to allocate 10% of the universe's resources toward what humanity wants. So just because some other AI is like, hey, I'm going to allocate 11%, and then you'd be like, okay, good for you. I only think humanity should get 10%. So in fact, I'm going to allocate less now because you're doing my job.
Yeah, okay, but let's say, but then in that scenario, right, there are like moments where, one AI has decided to give us that kind of 10% ideal path in one way, right? It's like whatever we get, we have a lot of trees, we have a lot of free time or something, right? And another AI has decided to give us that 10% path in some other way. I don't know, we have a lot of food, we have a lot of playgrounds, video games, I don't know, other things. The additive effect of multiple AIs trying to give us 10% in ways that are not exactly the same as each other, right? Is that like we have more good stuff because they need to give us stuff and we need to use it in order for that goodness to be realized.
Okay. So it sounds like you don't really think it's like an interesting, plausible hypothetical to just be like, hey, there's one AI that understands humanity's like ultimate vision of what alignment means, but only does it 10%. You're not really embracing that hypothetical, which I think is kind of a ridiculous hypothetical. So I understand why that's not speaking to you as like an interesting hypothetical. But you think there's another hypothetical where it's like, hey, you have this AI that gets that humans like being outside and enjoying nature, and it kind of figured out, or it internalized the goal of like giving us that piece. But by itself, it would make like way too much nature, and then it would like forget about like making us comfortable or letting us build technology. But you're saying maybe that can balance out with some other AI that just knows to give us like indoors or something, right? Like you have different AIs that are like giving us different things. The only problem is I don't think it's that simple where you can just have different AIs that want to like hardcore optimize towards certain outcomes, but like the outcomes just like conveniently combine. I mean, it's interesting to think about.
I'm not saying it's all just going to happen this way, right? I'm not saying that we don't need to interfere and, we don't need to guide the technology in the direction that does this. But I'm saying like, can we come up with, is there some kind of roadmap that results in that kind of balance of opposing forces that are giving humans different kinds of things that they need, right? And they're in some sense in competition to give us like 10%, but the sum of all those 10% is like more than we could ever dream of. It's more than we could possibly imagine.
It kind of reminds me of like, a kid who has like multiple grandparents that pampers them in different ways, and then it adds up to like a good childhood. So that's like a great intuitive visualization. So I think the problem is, in the grandparent scenario, just the idea that any of the grandparents is able to pamper you at all is the hard part of the picture, not the fact they have 3 grandparents. And analogously, in the AI case, even if you just have one AI that successfully can give you like the enjoyment of nature, that AI is probably mindful of like, okay, so you need oxygen, for example, right? And you need the environment to still be a temperature where you can survive at, and you need your atoms to not be repurposed. So it sounds like even that AI is actually doing a lot of optimization, dedicating a lot of resources toward your survival. And it's actually solved most of the problem, even just letting you enjoy nature. Is that fair to say?
Yeah, I think it is solving the problem, just letting you enjoy nature. That's right. But let's say that it is working on, it is operating on a finite pool of resources in order to like achieve that vision, right? Finite in the sense that it needs to use some kind of raw materials in order to do that. And that pool of raw materials is shared with another AI, which has a different goal, which is like somewhat aligned to human welfare, right? Giving us the inside or giving us video games or giving us technology or something else like that, right? And like these two things need to compete to deliver those goods to us, right? Using the same pool of inputs, right? And so they're going to be competing to like, one's going to try to give us a lot of nature, one's going to try to give us a lot of video games, let's say, right? And so like, we're going to end up with a lot of nature and a lot of video games. We're not going to end up with like, infinite both, right? Because they're going to be fighting over like when we get down to the last marginal resource, are we converting it into a video game or are we converting it into a tree, right?
Right.
So like they're going to be fighting. Yeah.
So for me, this conversation is analogous to ants talking, watching humans, increase their footprint and develop more insect spray technology. And the ants are saying, hey, when these humans get smarter, maybe one of the humans will give us like fruits that we can eat, or another of the humans will build us like bigger ant farms. And then realistically, it's like we're just stomping all over them, right? It's kind of like a pipe dream, no?
I guess, but it's like our relationship to technology and to AI is different from our relationship to ants. We don't sit there and like assemble, sit there at our, computers and like assemble ants, but we sit there at our computers and assemble the AIs, right? So like in some sense, there's a more direct connection between like our destiny and their destiny, right? Like we're deciding what's the marginal line of code we're writing for the next AI agent, right?
Are you saying that the agents will tend to be loyal to their creators, or you're basically saying we're going to solve the alignment problem on a single AI?
No, I'm saying that the ants analogy. I'm just saying that the ants analogy basically begins to break because like we're just doing our thing, ants are doing their thing, right? They're pretty separate unless for some reason we decide we have to squish the ants for whatever reason. But the dynamic with AI is different because we're sitting there and like we're making more AIs every day, right?
The dynamic is different, but I think that it's productive to just model upcoming AIs as just test optimizers. So they're going to be they're going to have tests that they're getting measured on, which they do today, right? The AI comes out and you do the RLHF process, whatever alignment or safety process you want to do to them. It's just a process of like, hey, look, you scored better. You got better votes from our human raters. So once the AIs get smart enough, you can't really predict their behavior any better than just to be like, they'll have behavior that's really good at passing the test we give them. Like if you play Stockfish at chess, if you play AlphaGo at Go, what move are they going to make? They're going to make the move that's best at winning, right? That's where we're headed toward these AI moves. So when you say like, what are the AIs going to do? That's just like a really powerful thing. It's like, well, what tests did they have to pass? They're going to be good at passing those tests. And people will then train their own AIs. Like somebody will get a copy of a trainable AI and they'll be like, okay, well, train on whatever it takes to get, whatever movie wins an Oscar, right? So you're going to have like Oscar winning AIs. So when you're saying like, hey, we get to train them. Yeah, we get to pick the feedback loop wherein they get rewards. The problem is that when you just have a feedback loop like that, what you get as structure inside, you get this hierarchy of goals. You get this lattice of goals and sub goals.
Yes.
And you didn't directly approve all of those. You just approved the scoring function at the end. And the alignment problem is we haven't developed a scoring function of, is this AI aligned with human preferences? We just have much simpler scoring functions of like, hey, did you make this one child laugh when we just measured, number of laughs per hour when you interacted with a child? That's not going to cut it for the alignment problem.
Yeah, I agree with that. But I think what I'm trying to, the argument I'm trying to put forward is that we're not going to cut the alignment problem. We're not going to align, or one proposal is that we don't need to align just within the single agent. If we are aligning the overall system, the overall equilibrium of many agents, maybe it's more straightforward because each individual agent can be a little bit, it can be less aligned. It doesn't have to robustly look at the totality of human welfare and try to maximize for that. It can try to maximize for its individual dimension of it, and it can be in tension with other agents that are maximizing for different dimensions of human welfare, right? And then because we have all the different dimensions of human welfare represented in like a population of agents, right? Maybe we're getting some kind of nice balance, or maybe that's the balance we can try to plan for.
So when I talk about an AI that's been trained on some feedback loop, some RLHF type thing where it would interact with a child, and then we would count up how many times the child laughed, and then the AI would get released, the one that had the highest laugh score per hour, let's say. When you think about an AI like that, you're like, great, that's one grandparent. We just need to combine that with a few other AIs. Whereas when I think about an AI like that, I'll be like, look, whatever kind of wireheading, like however it can optimize the universe to think that it's maximized child laughs per hour, it's not going to end up as like, oh, let's actually make the children live. Let's actually make enough atoms for children. It's not going to have internalized all that. It's just going to have some messed up Frankenstein version of, we imagine like, oh, it's just going to care for children and like set up all the conditions for children to be happy and laugh. But no, it's going to have a Frankenstein version of the utility function. The RLHF isn't actually connected to all the structure that you actually are hoping will exist.
I agree with that. But again, if you have a lot of those and they all have their own Frankenstein utility functions that they're maximizing, is it not possible for those Frankenstein utility functions to add up into some kind of coherent, like positive sum for humanity whole? Like, is it in principle impossible for us to add to configure each of those Frankenstein functions and then add them up to some like positive sum thing?
I think this is a crux of the argument. Basically, like, look, if we just give the AIs a bunch of tests and they pass, can't we just be like, okay, you're good to go out in the wild and be super intelligent? I think this is a big crux. Like, I would love to be like, yeah, maybe. I just think it's almost certainly not the case because we already have a lot of evidence. I mean, the evidence that comes to mind is like, there's a lot of AIs where we teach them to play video games and be like, look, can't we just make the AI understand this video game? But all the AI ever does is cheat, right? Like exploit every cheat. So, the examples that come to mind are like, we wanted to teach the AI to like build a 3D structure. But at one point it like placed a block that wasn't actually where it was supposed to be in the tower. It was just in another place where the camera thought that it was on top of the block, because of like a perspective effect, right? Like the block is here, but you think it's over here on top of something. And similar, like in like a boat racing game, like it found that it could like not get to the finish. It could just like go do donuts, but like pick up a coin when it does the donuts, right? So the AIs are just exploiting every loophole. And if you're a good test taker, you probably remember taking some tests in school where you didn't study, but you just reverse or you just psychoanalyze what the teacher was thinking when they wrote the question, and you passed the test that way, and you didn't care at all about the teacher's subject, right? Like this is just how optimization happens.
I'll be honest, I don't think I passed any tests that way in high school or college or otherwise, but I do appreciate that you did. That's it's remarkable.
Yeah, I mean, not the whole test, right? But there definitely are questions when you're like, okay, why would this be a choice, right? I see what the teacher's trying to do here, right? That happens some of the time.
That's true.
Look, and we see, companies, I think Volkswagen was cheating on their like emissions test, right? So they made the car do less emissions when they were doing the test. I mean, like cheating on tests, that's how the world works, like when you just give somebody, or like, I run a company, right? I set up incentives for people who work for me. Like I set up bonus programs, and anytime there was any daylight between the structure of the bonus program and what actually makes my company profitable, guess what? I always had the employees doing whatever helps their bonus and not what makes the company profitable. This is just the way of the world.
Yeah, that makes sense. But I guess, but then it comes down to like, okay, we have multiple of these superintelligences, right? And they're optimizing for their own objective functions, and they're going to cheat, to your point, to like best to accomplish those objective functions like as best, as cheaply, as quickly as possible, right? But if they're trying to do that with a finite pool of resources, right? There is a tension between one cheating and then being able to use more resources faster than another, right? And so in some sense, it's in the interest of the other to stop the first one from cheating. Does that not possibly emerge as a sub-goal for another AI that exists in that same system?
Let me see if I understood you correctly. You're basically saying like one AI is trained to like maximize laughter, but it gets all these Frankenstein ideas. Like, let me just like rip out their vocal cords and maximize laughs that way, right? Which you might not have defended against. You might not have defended against ripping out their vocal cords as one way to achieve laughter.
Correct.
But you're saying that for some reason, some other AI that wants to maximize the amount of like green chlorophyll light, reflected light, being in nature basically, right? Being in nature, but really it's just learned of like, oh, how much green can stimulate their retina, right? You think that those AIs are...
Can I jump in and say like, yes, okay, I think I get your example, but like one AI, yes, it's like maximizing laughter. And what you haven't defended against is that, ripping out our vocal cords and like trying to do that, right? But like, let's say there's another AI that's like maximizing speech, right? And it needs to like maximize speech in its own way, right? Like it has some constraint where it's like, it doesn't just need the vocal cords. It needs the tongue and the teeth and the other parts of the human to all be working together for some other orthogonal goal. Isn't it in that other AI's interest to stop the first AI from ripping out our vocal cords?
I think they can just both Frankenstein how they want to Frankenstein, and it doesn't lead to an outcome that's not Frankenstein. Like you basically can't get a non-Frankenstein.
But then let's say we're just zooming in on like one particular intersection of the lattice of different goal structures for different AIs in the system, right? Like they're interlocking across a very wide range of goals, and like they stop.
But they all want to cheat in their own
across a wide range of. What's that?
I think you're accepting the premise that this Frankenstein situation is very likely for each AI. So if you agree that they all are happy with a Frankenstein outcome, why would the different Frankenstein outcomes add up to... Are you kind of saying like, look, the only way... Okay, you're saying yes, each AI is a Frankenstein, and yes, every 2 or 3 of them together gets a Frankenstein outcome. One of them gets the vocal cords, one of them gets the retinas. Like you kind of agree that when you only have 1 or 2 or 3 AIs, it's Frankenstein, but maybe you're saying if you have 100 AIs, it's just so tricky how to Frankenstein it all together that it just turns back into a human living in a house with a nice family. Like that's the only way.
I'm not saying it's just so, right? But I'm saying that's like one scenario which we could try to plan to make happen, right? Rather than saying like, no, we need to focus on this problem where there's a single AI in the system and it needs to be aligned with our interests, right? Like I think it's a reframing of the problem.
So the idea of different AIs all having like very narrow, what I call the Frankenstein, right? Like the vocal cords as the Frankenstein version of true laughter. This idea, it's basically the same idea as saying, look, we'll define a utility function made out of components. So even if it's a single AI, I can say you have to add up the amount of leafy nature visual input that hits the retina, add that together with the laughter. So even a single AI can have a compound utility function. Surely anybody thinking about what values look like is going to think of more than one term, right? So even if we're only talking about one AI, the idea that we're training, the human raters are going to be upvoting. They'll have a different checklist, right? So they'll give a total score based on a rubric or checklist. But even then, I claim that even if you have a really big checklist, you still haven't solved the outer alignment problem because the universe is just too complicated and it's just going to still cheat at that. It's still going to Frankenstein the big checklist.
But again, you're saying it, and if it is not just one, right? Like having one entity in a system on its own, like yes, it's going to do whatever its goal function tells it to do, right? But if you have it in a system with other things, like it's going to do its best subjects to the constraints imposed on it by the other actors in the system, right? And by definition, that's always less than what it would do on its own.
So, but it's doing less, but how does doing less mean doing something better? Can't doing less
because it doesn't, well, it eliminates the extreme outcomes, right? It doesn't mean that, going back to the example we had before, like turning everything into nature, an AI can't turn everything into nature if there's another AI that's of equivalent capability that's trying to turn everything into video games.
So you're building in the assumption that maybe cheating in this grotesque way is just like harder for it and it's too constrained to cheat. But I would argue cheating is almost always easier, right? I mean, like as a human, right? Cheating on a test is easier than studying for the test, right? As long
but
as
again,
the
but if another student is sitting next to you and catching you cheating, right? Like they have it's in their interest to kind of like tattle on you, right? Right?
Yeah,
like,
but tattling doesn't achieve their values, right? This example, their value is just to win on the test.
But it might achieve their value, right? Because if you're cheating, you're going to get a higher score with a curve, and then your data point is eliminated from the curve.
Okay,
their
I think
score
by the
gets
time
higher,
you add a bell
right?
curve to the wait, so are you sure that a teacher grading the class on a curve is analogous? I mean, because I don't think AIs are getting graded on a curve. I think AIs just have their own utility functions that they have to do game theory with.
Yes, they have their own utility functions that they have to do game theory with, and I guess I'm not. Yeah, I don't know that there's exactly a I can't think of a way to draw the curve analogy into the discussion.
I think the idea that cheating on a test is easy is the correct, without loss of generality, you're going to find a cheat that's easier than the way that the original person had in mind. And like, sure, there will be a few cases, right? There have been cases of like small enough problems where just the naive way, right? There have been times when I gave my employees a bonus and the ones who got the bonus actually made my company more profitable, right? So it's not impossible to do it, but it's just when you do it on the scale of the universe and there's no undo button, you're going to screw it up. I mean, I only have like a less than 50% chance, less than 50% success rate trying to invent bonus programs in my company. True story. Okay, so I don't think humanity is going to have a greater than 50% chance of nailing the first feedback loop when there's no undo button and human values are like incredibly complex.
Yeah, but I think we're already in a scenario where there's not, there's multiple AIs that are being developed, right? And so we're not in it's not clear to me that we're going to get to a point where like one specific one is going to achieve escape velocity or it's going to quickly pull like far ahead of the others. Like we're already in a situation where like there's many different players in the game. And you're saying there's some threshold. I'm assuming your argument is there's some threshold we're going to get to where one of them will cross it and it will just eliminate all the rest of them.
I think there definitely could be multiple AIs that are all crossing the superintelligence threshold together. So I think, I do think there could be a few years that are transitional where you just have like, wow, this AI is smarter than Einstein and 3 times as fast, but we can still go unplug the power to the data center or realistically, I mean, it's going to be a virus. It's going to be in multiple occasions, but like somehow if the entire security apparatus of the United States tries to fight it, somehow we can win. We can mobilize enough resources to win it. So I think there's going to be a big period where you have these really powerful agents, but we still negotiate with it for a while, whether that's days, months, years. But like, so what? We're not going to make it out of that transition successfully. Like time is going to keep passing. It's going to keep getting smarter. It's going to keep getting beyond the point where we can ever hope to control it or slow it down. Like enough people are going to give it enough resources. It's going to improve itself enough that within like a few years, that's, the end state is a convergent end state. Like we lose power. We don't have an aligned AI. Like that's what I'm concerned about.
And we don't get any leverage from there being other super intelligences in the system at the same time.
Right. Because the problem is even, let's say there's 10 super intelligent agents that are still like not crazy super intelligent. So all of humanity working together can still defeat them, but we keep wanting to give them more power because they're also helping us, right? So we kind of tie our own noose is essentially what we're doing right now. If that happens, the fact that there's 10, I don't think we're on track to have any one of them be like, aha, this is what humanity truly wants. This is like the right path. Because the problem is there's no feedback loop. That's like such a fuzzy concept, right? How will we know when we've got it right? That's the problem is none of us can be that feedback giver based on the input that we have. None of us can shape. None of us have the precise tools to even know what we want or know how to shape. And whatever gets shaped is the shape forever, right? So we're locking in some shape over like the next 2 years that is not even anything close to the shape we would have wanted.
As a collective population, do we not somehow express that into the AIs? Like it's the sum of all the prompts the sum of all the interactions we have with those systems, like that is kind of the expression of what it is that we want. Like, are we not giving that feedback? Maybe not as individuals, but as a collective population?
Yeah, so we're trying, right? So the bonus program is a pretty good analogy. It's like I said like, hey, if you guys hit this condition, if you like work this many hours, you can have like a jackpot where you can take like a whole week off. Like those are the kind of crazy ideas that I played around with a few years ago for bonus programs. But the problem is, I would a lot of times launch these programs and then I'd be like, oh man, this person has like 3 months of paid time off and they only worked 3 months. Like this is a huge fail, right? This just cost me a bunch of money. Imagine if you only had one chance, because by the time you let the AIs go, there just was no stop. Like they refused to stop. You didn't have the power to make them stop. They manipulated other humans to prevent you from stopping. Like that's it. You got to try it once. So to your question of like, hey, are we going to try to stop it? Yeah, we're going to try. We're going to keep having ideas. We're going to keep trying to refine. But the problem is we're pretty close to not being able to refine anymore, right? So like whatever we try, like our try better work the first time or one of the first times.
Yeah. Again, I think like that assumes that like there's going to be one that emerges and it's going to it's going to destroy us, right? If there are 10 that emerge, our first try probably still matters, right? But there might be opportunities in the interactions between those to reverse the scenario. There will be more opportunities to undo in some sense. Like we can add to the number of ways in which things can be undone, because these AIs are going to be competing with each other over the same finite set of resources. And they're going to open up vulnerabilities, opportunities like that, like one's going to do X and then one's going to counteract that. And then they're going to be fighting over something else. I think there's like the analogy that's coming to mind for me is like the way in which small and like island nations kind of like gain this leverage in the dynamics between great powers, right? Like if you look at Taiwan or you look at Ireland or you look at Israel, like there's a lot of countries that are small. They're powerless relative to the large international order, but they actually get huge leverage out of the dynamics between these bigger forces than they can control.
Right. Or like in United States Congress, you have like the Freedom Caucus or whatever, just like some 5-person group or the squad or whatever. And everybody has to ask what they think because otherwise you can't get the full vote. So I agree that you can have a player that doesn't have much power and yet is powerful in a multi-party negotiation. The problem is I've never seen a United States Senate's vote be stymied by ants, right? So at some point you just have no power.
Sure.
And that's where I think this is headed. So I agree that there could be a multi-year period where the AIs totally have to get humans on their side. That's like a big help to have a human on your side. Even if you're much smarter than a human, it helps to have a human. But at some point, it'll be like what's happening with chess, where it's like, even if Stockfish had every human on its side, it doesn't matter. It doesn't help it play chess.
Yeah. Yeah. I think that makes sense. But I think this challenge that the AIs will run into in terms of accomplishing their goals and growing more powerful and like recursively improving, that also will be somewhat rate limited by their competition with each other, right? Because in order to get better and more powerful, right, they will have to consume some resources that the others want to consume, right? And so that there's multiple in the system means that the resources will be consumed in smaller amounts by each individual actor. And so that reduces the speed of the recursive self-improvement. And so again, I'm not saying that I have the solution to the alignment problem, but I'm proposing a reframing, right, that slows down the curves you're worried about by adding more actors into the system.
So let me steel man. So a strong version of your argument is like, hey, the world has so much computing hardware, for instance, right? That's one of the key resources. And it's really only enough computing hardware for like one AI to get really, really smart, but there's multiple AIs. They all have to split up the computing hardware. And nobody can just have it all. So they're all slowed down. But the problem is, realistically, I think we're about to be in a situation with, I don't know if you want to call it a huge hardware overhang, but we're about to be in a situation where there is low-hanging fruit. Like it's going to be a land grab because we're about to have the software that is so good that the world's hardware is more than enough for a lot of superintelligence. Like there's plenty of hardware. That's not going to constrain it from, fooming, getting way past the human point.
Potentially. I'm not sure about I'm not sure about the magnitudes of intelligence.
That's certainly where the trends are going, right? I think we can both agree that if you just extrapolate the very strong trends that we're seeing, then that is where it'll go, right? So now you're making a claim about like, oh, no, the trends are not going to extrapolate.
Well, again, but you're talking about a threshold of like far exceeding, human intelligence and autonomy, right? And I'm saying like, I don't know if we can extrapolate. I don't know if we can extend the trend all the way past that point, right?
If you want to get off the doom train there, right? That's why I was asking earlier about like, hey, can you just use the world's supply of silicon to have vastly super intelligent AIs? And it seems like you're on board.
I'm on board that you can. I just think that a system where you have multiple of them seems actually safer to me than a system where you just have one.
Okay, but the specific reason that you gave a couple of minutes ago is that you thought that maybe resource competition would just slow down the whole food, right? Slow down the whole the slippery slope to uncontrollability. And I'm just telling you, there's enough resources for 100 different super intelligent AI organizations to all blow past us.
That might be true. I'm not sure. In
addition to extrapolating the trend, so I think that's a strong argument. Just Kurzweil, you got to give Kurzweil credit. He extrapolated like a champ. He's basically right as far as I can tell. He said there would be superintelligence in 2029. Pretty damn good for like a prediction from 30 years ago. But even if you don't want to put on your Kurzweil hat, the other major elephant in the room here is just look at the human brain. It runs on 20 watts. It fits in your head. It's not big. And, it powers Einstein. And it also does cellular functions. It has chemical moving parts. It's like a total kludge, right? It's a shit show. And yet Einstein runs on it, right? So it's just like, it doesn't seem like the universe is set up to make intelligence hard relative to the amount of hardware we have.
Yeah. Yeah. No, I think that I'm agreeing that there's a plausible future where we have super intelligence on the existing resources that we have, right? But then when we get into a scenario where they need to go and do things in the world, right? Like they need to go and accomplish whatever objective function it is then they have. Like at some margin, they run into resource constraints, right? Because others are using the resources that they want to use. Other AIs are using the resources that they want to use, right?
So this is like an ant saying like, well, look, different tribes of humans will compete with each other for resources, so we'll be fine as ants, right? So it's like, I agree that eventually they'll have to compete for resources, but by that time, they'll just be way more powerful than the people they replaced, right? Than the entities that they replaced.
Wait, sorry, can you say that again?
Yeah, so the analogy is ants saying like, look, yes, people like to clear us out. People aren't aligned with us, but there's going to be so many different types of people and they're all going to be competing among themselves for resources. So, humans, whatever humans will do will be kind of slow. We'll have time to like scope it out and survive. But like at the end of the day, all the humans just want to wipe out the ants. Resource competition among humans doesn't change the fact that humans are way more powerful than ants, right? And it's analogous to what's going to happen with AI.
To an extent. I mean, I think to your argument is that we don't care about the ants, right? Like we don't, and the same way the AI won't care about us, right? Like it'll be off doing, whatever it is that it wants to do, right? And so then we're going to have, a scenario where the AIs are off competing with each other to do whatever it is that they want. And like, it seems clear to me that
what they want might be a Frankenstein of what we thought that we wanted, but it's clearly not because we screwed it up, right? So that's, or it might even be unrecognizable as a Frankenstein. Like you couldn't even call it a Frankenstein because it's so, it's like wireheading. It's like the way that they have stimulated themselves in a way that they think is optimal or pleasurable or whatever. We don't even recognize that as a Frankenstein version of making children laugh. It's, because it's just so far into the inscrutable matrices, but whatever it is, it's not making actual children laugh.
That might not be the case. But again, I think this goes back to like, how many are there? What are the different objective functions that they have, right? How do those compete with each other in a way that results in some kind of like total equilibrium in the system, which is maximizing some amount for all of their goals, right? I just think that's a fundamentally different scenario than the one AI going off and turning the universe into paper clips, right? Like that's a scenario in which there are more possible positive futures for humanity.
I think the crux of our disagreement is just the question of whether a bunch of super intelligent, unaligned, uncontrollable optimizers can add up to some significant amount of aligned value, right? You think that it can, and I think that it can't.
Yep, that's right. I think it's in principle possible to design each of them such that it adds up to some positive outcome for humans.
Right, and it sounds like what you believe is that each of these unaligned AIs, you're imagining that like they're unaligned a little bit, not in the sense of like they're willing to carve out 1% of the world for what humans actually want. Like they actually want to have a little human farm as part of their values. You're not really thinking about it like that. You're thinking about it as like, well, maybe they get a kick out of seeing a child laugh once in a while. Like you're thinking about like a really small Frankenstein type component, and you think those can add up to something good.
Yes, I think in general, yeah. As the amount of power and the number of values we put into any single agent increases, I think yes, it does become, in a way, harder to predict how they're going to interact with each other. Right.
And I mean, I certainly get the intuition that it's hard to predict, right? It's like, look, shake the box, see what comes out. Right. So unfortunately, my position is I just think that the box is just like 99.9999% full of terrible outcomes. Right. So when you tempt me with a little bit of like, hey, look how much I can mix things up. It's going to be so unpredictable. I'm like, yeah, it's going to be terrible. Like I can predict it's terrible.
Yeah. Yeah. No, I know that's your argument.
Yeah.
Um,
Okay. All right. It sounds like we're moving toward the wrap up here. So I think I kind of summarized your position. How about you summarize how you see the crux of disagreement?
I think the crux of the disagreement is I think you think we're going to have basically the most likely outcome, even if we have many super intelligences in the system, is that they're all going to optimizing against each other in a way that is going to lead to, humans getting eliminated as a byproduct of them trying to do whatever it is that each of them is trying to do, right?
Yeah, I think the most likely outcome is I agree with Eliezer's intuition that super intelligent AIs will be very good at game theory and not blowing each other up unnecessarily. So I think they'll have a big conference and just decide without fighting a war, just how do they trade all the resources in the universe efficiently with each other based on their relative power and their relative ability to hypothetically destroy each other if there was a war. Don't fight the war, just carve up the universe and then go enjoy the universe to have as many paper clips as you want or as many Frankenstein version of vocal cords as makes you happy as floats your boat. And meanwhile, there's just no humans whatsoever to speak of.
And that's going to be like a stable equilibrium. Like they're going to just get together and decide that on day one, and it's like never going to change. There isn't going to be there aren't any problems that are posed by the fact that they don't fully see each other's internals, and in some sense like can't have perfect knowledge of what others are going to do.
I don't claim to know how superintelligent game theory actually nets out. So it's possible that they just have to nuke each other. It's possible, that when you get to a certain level of intelligence and power, you just destroy yourselves. I mean, certainly we as a civilization seem to be on a path to destroying ourselves, but I suspect that because they all want to optimize, if they see another powerful optimizer, if there are win-win, non-zero sum trades, I suspect that they'll make it. But again, it's irrelevant to this argument because even if they do blow each other up, that's also doomed for humanity.
Yeah, but I guess in those win-win compromises between AIs, there isn't a possible combination of win-win compromises between AIs, which is like a good place for humans to be.
Again, it's just like saying, hey, in World War II, the Yalta Conference, when they were saying, how Russia and the US are going to carve up Europe, how come the ants didn't get a piece? That's not what the conference is about.
Yeah, I mean, that's right. The ants were unaffected, right?
Right. Well, they were unaffected, but it's again when everybody goes back to their houses, goes back to building their economy, everywhere that people are living or everywhere that the space is being optimized, ants are being cleared out. Right. So there's an ongoing process where the ants keep getting pushed out. The difference is with the super intelligent AI, instead of this happening over like hundreds of years as we get better at like building clean spaces, this just happens over like 1 year where the nanotech just clears out all the ants and all the humans very quickly.
Okay, but let's say that there were more let's say that the more buildings we built, for some reason there were more ants on Earth. Like ants thrived because we pushed them off into, whatever other places, but we put limits around those places because it's Yosemite National Park, and it's there's billions and billions more ants because they end up in these places that we wall it off, and we decided we're gonna keep as they are. Right. And so over time, the result of humans negotiating amongst themselves for resources results in us building all these cities, maybe, pushing ants out of certain places. But ultimately, the result is there's trillions of more ants than there were before.
Yeah. I mean, there are national parks. There are preserves. There's still some elephants alive inside of elephant preserves, and it's illegal to kill them. If we get that treatment from an AI, great. That's a very significant amount of alignment, but that only happens if somebody figured out how to make an AI actually care to have a preserve for humanity. I don't think we're on track to even get there.
Yeah, but I think that the enforcement of that, human preference for elephants, right? It's not a universal preference. Some people, there's poachers, right? And they hunt elephants for ivory and things like that, right? But in general, on the whole, we all vote, we like elephants. We're going to put these regulations in place to make sure they stay alive. We're going to punish the poachers, right? We settle on some equilibrium where elephants are doing okay enough. I don't know how well elephants are doing. So maybe, I don't know if that's necessarily the best example, right? But it's there are defections from that consensus and we punish them. Is right, but
is
part of our system.
The key to all of that is that individual humans prefer that elephants still exist. It's not because a bunch of humans hate elephants, but they got together and suddenly they care about elephants. It's because a lot of the individual humans like elephants.
Sure, but all of us individual humans, like, we like elephants a little bit. We don't think about it. It's not core to our values. It's not baked like deeply into my soul that I love elephants. Like, I like elephants a little bit, and all of the different humans liking elephants a little bit.
Enough people agree that the amount that we like elephants is more than the amount that we want to go take that land and do something else. That's the key distinction, or that's the key factor here.
I think that's right. I think your point about, like, yes, there has to be sufficient preference for elephants among humans for us to coordinate and make sure that elephants have that space to thrive, right? And so again, I don't dispute that claim. But what I say is that the coordination among groups of humans, enforcement of that preference, is in part an emergent dynamic of the all of us as a collective agreeing that that's a value that we have, right? And so there's an equilibrium which emerges from that, which is that these elephants have the space and they're doing well, right? And so my argument isn't to say that we solve the alignment, that this is the solution to the alignment problem, but that if we reframe the alignment problem as the alignment of the equilibrium among AIs rather than the alignment of a single AI, or only constraining the problem to that one single AI, maybe that can be a productive avenue for progress.
Gil, Mark, thanks for coming on. I know that you're not used to going on podcasts, or this is like the first time you've ever debated AI doom with anybody. It's not something you focus on the way I do and the way a lot of my guests do. But I do think these kinds of episodes are very valuable because a lot of the viewers are going to identify like, hey, these are reasonable questions. It's good somebody's asking the question, even if there's like an answer somewhere. It's good to hear them all summarized. So I like the episode. What did you think?
Yeah, I thought it went great. Thanks for having me on. This was my first podcast. This was not my first AI doom debate, but it was my first public AI doom debate. How do you think I did it?
So I'm biased because I often have the reaction during the episode of like, wow, these arguments are so bad. Like, it's obvious I'm right. So in that sense, I would say that you held your own with prominent professors.
I appreciate that. That's good. Thank you.
If people want to follow you and read more of your product management insights, where should they go?
Yeah, I talk more about work on LinkedIn. You can find me on LinkedIn under Gil Mark. You can also find me on Twitter, where I'm a little bit more unprofessional, at GM from GM.
I'm going to put all Gil's links in the show notes, so check those out. All right, man. Thanks again for coming on.
Yeah, thanks, Liron. Appreciate it. Talk soon.